Hey guys, it's Tara. Today I wanted to do another section of the photography project, mainly the chemistry of the film and the photos themselves. So there's a lot of equations for this, so I wrote them all down, so we'll get to those a little bit later. But there's a lot of different chemicals involved. It's not as much as you might think, but it's still a good amount. So one of the things that is involved in is that the chemical that I talked about in another previous video is the silver halide salt, which in turn is silver bromide. So the chemical formula for silver bromide is AgBr. It's a capital A lowercase g because that's the symbol for silver, and then capital B lowercase r because that's the symbol for bromine. So as we talked about previously, when the light strikes the film, a reaction occurs and produces a free atom of silver and a free atom of bromine. So there's an equation for this. I actually wrote it down, and I don't know if you can see that. Here, I'll zoom in a little bit. My version of zooming in. So as you can see, I wrote down silver halide salt, which is actually silver bromine, and I wrote that over there. And then so the equation for that is Ag plus bromine, which has a negative charge. And then that is, it's a crystal at this point, the bromine. And then you add Hv, which is radiation, which can occur especially when you're working with light. So then you also have, that becomes silver plus, which means it has a positive charge, and you have bromine plus, and you have an electron. That's what the E is. If you see over here, that's E minus, electron negative. So the silver ion, which is the Ag, because once you give it a charge, it's now an ion. So you have the Ag, and then the silver ion can combine with the electron to produce a silver. So the next equation I wrote down underneath that one, right here, that's this equation, is Ag plus, you still got that plus from before because it's from the previous equation, plus the electron from the previous equation, which is over here, and then that will give you silver oxide. So the silver halides, then they become dispersed in the gelatin that makes up film. So like film, you know, have you ever heard that film is like made up of, in Jello there's like pig's film and stuff, and Jello's kind of like a gelatin. So it's kind of like that. So film is almost like a gelatin. And there's called, I'm going to pronounce this wrong, please excuse me, emulsions, which are silver halides that are sensitive to light. And they're suspended in this liquid gelatin film. So the silver halides themselves, they're silver bromide, which I already talked about. And then you also have silver chlorine. So now silver chlorine, if you don't know the chemical symbol for chlorine, it's Cl, capital C, lowercase l. So it would be AgCl, and of course AgBr. So those are your two. And what else do we got here? So the silver Ag, it will always be combined with either Cl or Br. And so if you keep going along with this, so far, I mean, pretty simple, self-explanatory. You got some things reacting, Ag plus Br plus Hv, which is the radiation, and then that just becomes Ag plus Br plus an electron, which then goes into another equation, which is Ag plus the electron, and that's where you get your oxygen and the silver. So the chemistry involved in development has to do with the increasing amount of these silver halides, and the grains begin to develop, and that's where you get so many more silver halides once, because as I said before in a previous video with the light, I'll put the link in the description if you haven't seen it. I talked about how the light, once there's that brief moment of exposure, and once you have that brief moment of exposure, the silver halide starts to react. So once you have all these different ones reacting, it just kind of starts a chemical reaction. And so as the grains I can't talk. So as the grains begin to develop, and they speed up the development process, and so chemistry is used during a stop bath, which if you have seen my Prezi, again, I'll put the link in the description. The Prezi explains the steps to develop the film. I believe that's part 4, so it would be what should come right before this video if you haven't seen it. So the stop bath is one of the steps during when you're developing the actual film, and so the job of the bath is to halt the development. And so since the developer usually has a very, very high pH, a weak acid is used to contradict this. So since it's like basic and then acid, if you follow the pH scale, 7 is neutral, basic is towards 14, and acid is towards 0. So if you're doing that, then you have something very basic, and something acidic will contradict that because they're on two opposite ends. So again, another step of the process is the fixing process. So chemistry is also used here a lot, as there are so many different reactions that take place during this, and the fixing stage is where the halide is removed from the image so that it doesn't continue to darken, because you don't want your picture to be really, really dark. So due to the fact that the halides are only slightly soluble in water, they have to be converted into water-soluble materials that can be washed away so that your film comes out correctly. So I wrote these reactions down too because I figured it would be helpful. So that's on the other whiteboard. So here you have your 3 main equations. So on the first one that you have, it's Ag, I don't know if you can see it, it's AgBr, which is silver bromide, as we've said before, plus S2O3, which has a 2- charge, and that becomes AgS2O3 minus, plus Br minus, and it's an absorption complex. And I think I spelled that wrong up here, so we're just gonna cover that. You didn't see that. But yeah, so what happens here is it's a single replacement. I don't know if you guys know what that is, but in chemistry, a single replacement reaction, it just means that if you look here, it's AgBr, and then it's S2O3, and so what happens is if S2O3 is stronger than Br, then they switch. And since there's only one thing switching, it's a single replacement reaction. So then your next reaction that you have is number 2, and I'll zoom in on these a little bit so that you can see them a little better. So that one is AgS2O3. Again, you're getting that from the previous equation, and then that will become Ag quantity S2O3, which there's 2 molecules of that, that's why it's in the parentheses, and that's a 3- charge, and this is considered desorbed instead of absorbed. It's desorbed. So the next equation, yeah, there's a lot of equations. It's a little confusing. So here, your last equation is reversible. So there's arrows going both ways. The reaction can happen both ways, so I just wrote it 2 different ways so that you can understand it a little better. But it's Ag, and then it's from the previous equation. Again, you have the previous equation, so that's this product, which is Ag quantity S2O3 with the 3- charge, and then that turns into AgS2O3 plus S2O3. So again, that's it becomes AgS2O3 minus plus S2O3 2 minus. And then again, it's reversible, so if you reversed it, it would be AgS2O3 becomes Ag plus S2O3 2 minus. So now the time needed for fixation, it varies on the amount of development, not development, what am I saying? The amount of thiosulfate in the solution, as well as temperature and agitation. So the gelatin will need to be hardened after development, and this process of hardening is often combined with the process of fixing. So let me just move those equations out of the way. The chemicals that are used, there's three chemicals, and I didn't write them down for you, I'm sorry. So the first one is acetic acid. I'll put it in the description. I'll write the chemical formula for that because I don't have it off the top of my head. But it's a polyatomic ion. And that creates the proper pH for hardening. Then there's sodium sulfite, which again you have your sodium, which is Na, and then you have your sulfite, which is a polyatomic ion, to prevent staining. And then you have alum, which is a hardening agent. So now that you have all these different chemicals reacting with each other, the hardening occurs when the aluminum ions, they react with the carboxyl groups of the gelatin, which forms like these cross-linked chain molecules. And so there's a lot of chemistry within this, and I'm just going to do a quick review real quick. But pretty much it all goes back to that silver halide salt, which I talked about in my previous video. So if you just remember silver halide salt, if you don't remember anything else from this video, silver halide salt, silver halide salt, silver halide salt. So you have your equations. So this is the first set of equations. And remember, silver really likes bonding with chlorine and or bromine. So that's your first set of equations. And then you have your second set of equations. Okay. So this is your second set of equations. These are your reactions now in the second part, more towards the fixing process, which is the development of film. So that's pretty much it. Chemistry is used in basically every step of the process, and I think that's why this project was chosen, because there is so much chemistry to learn from, and everything has chemistry in it, and I think that's one of the major points of this project. But just to be learning about it, it's just really interesting, and there's so many chemicals, and they all just work together, and I think that's the great thing about chemistry, is that everything just kind of comes together at the end of the day, and everything is logical and everything makes sense. So I feel like that makes it a little easier to understand when you know that everything's going to work out and one thing goes from one reaction to the next. So I hope this video helped, and I look forward to talking to you guys soon. So thanks!